All right. This morning we're going to have a look at what we call the 68, 95, 99.7% rule. And I've alluded to this previously several times. This is talking about when you're going a certain amount of standard deviations away. So if I've got this normal distribution, I've got the mean in the middle, and then I'm going to mark these off as adding on standard deviation. So this is the mean plus a standard deviation. That's a mean plus 2 standard deviations. That's a mean plus 3 standard deviations. Sorry for the angle, but it just makes it a little easier for me to write. This would be on the other side, so it's going to be minus 2 standard deviations. Mean minus 2 standard deviations, and your mean minus 3 standard deviations. So to give this an example, so if we're talking about IQ, because we talked about it the other day, we've got a mean equals 100, standard deviations equals 15, so that's going to be 100, and then I'm going 100 plus 15, so that's 115. 2 standard deviations, 130. 3 standard deviations, 145. Going down, I got 85, 70, and 55. Now, where this rule comes in is saying what the area is here, what the probability. So this 8 ounce 68% rule is saying that within one standard deviation, we have a probability of 68%. This area here, I don't know how to draw that in. I'm just going to. Is 68%. Okay, and then if we go 2 standard deviations, maybe I'll just switch colors. That's going to be 95%. And I'm not sure if this will come out very well, but within 3 standard deviations, how do we do this? So including all of this area here, and this bit here, we get 99.7%. Now, that's all very nice and good. You're going within 3 standard deviations on either side. Sometimes you want to know just on one side. So what I'm going to do here is just divide them up into little sections. So we've got 68 in here. They're evenly distributed, so it's going to be 34 and 34%. Well, I've already accounted for 68 out of the 95. So if I do the subtraction there, that's 27. So half of that is going to be 13.5% in between 1 standard deviation and 2 standard deviations above, and the same at the bottom. And then I've got another 4.7%. We'll call it 2.3. It's close enough here. 2.3%. And got 0.15% on the tails. And as I've mentioned before, they do in theory extend out to infinity, but the vast majority of the 0.15 is in 1 standard deviation more than that. So actually, as we go out, it gets increasingly unlikely. Now, so this would mean if I wanted to know what's the probability that something's less than 1 standard deviation above the mean, all you have to do is add up all of these, and you'll find that it's 84% would give you all of those added together. All right, I will